Welcome back to Missouri Caves and Speleology. I'm Toby Dogweiler and I'm here with Dr. Doug Guzet. Today we're going to discuss living with karst, and we're taking that title and that theme from a publication that the American Geological Institute put out a number of years ago to inform people who live in the many parts of the country and the world on karst terrains how the geology of the area they live in interacts with groundwater and water resources, and how they can better protect those water resources. So we'll put a link to the pamphlet on the course website, and more information can be found in there about the topics we're going to discuss today. So many people in the U.S., about 20% of the lower 48 of the U.S. is roughly in that ballpark is karst, and a similar proportion of the world's land surface is karst. So many people around the globe and in the U.S. actually do live on karst.
Yeah, in fact, about 20% of the U.S. population lives on karst, but a significant portion of those people actually also rely on that karst for their water supply. Florida is one of the large states that is almost entirely located on top of a karst or limestone area, and most of Florida, because it's surrounded by the ocean, actually is relying on the groundwater from the karst as their water supply for millions. I believe that's about 17 million people.
Mm-hmm. And Florida is a good example to build on that, that in addition to the water, this water as a drinking water resource or an agricultural water resource, is also a recreational resource in many parts of Florida. Yeah. Many state parks in Florida are built around springs and so forth.
Yeah, it's also some of their tourism, the geotourism of Weeki Wachee Springs and all the mermaids that sometimes will perform shows in those springs. Yeah, it's a key part of their tourism.
Mm-hmm. And to come back, to bring this back to Missouri, in southern Missouri where we live, where Missouri State is, there are a number of state parks that are also built around major springs. Missouri has some of the most impressive large springs in the world.
Yeah, our trout fishing at Bennett Springs and Roaring Springs, and several caves even are also in parks.
Mm-hmm. So just to sum that up, karst provides us with water resources, recreational opportunities. The caves themselves are often cultural resources. So there's a lot to protect and look after in our karst terrains.
And as we've seen throughout the class, the karst is related to the sinkholes that may form, it's related to the water, it's related to contamination that could get into the water through sinkholes or even just through the land surface. Mm-hmm. So it really comes back into living. It's really not just living with karst, it's living with our world. It's how to understand the world we live in.
Another topic we covered during this course was the biology and biota of caves, and we've got some pictures here behind us about the unique life forms that live, so we're also protecting those ecosystems. And as I'm sure we both know, there are biologists, microbiologists out there who are sort of on the new frontier of now not just studying the macro critters like the crayfish, but some of the bacteria and microbes that live in caves that may be useful in helping to cure various diseases and so forth.
Yeah, Lechuguilla Cave in New Mexico, part of Carlsbad Caverns National Park land, is one of those unique caves that had the sulfur kind of formations. And so some of those sulfur bacteria, either some of the slimes that they produce or the, slime isn't the right word, I'm not a biologist, the things that they ooze out that not only help facilitate actually the way minerals form, may actually, there are several pharmaceutical companies I know looking into some of those things for potential cures or vaccinations and treatments and things like that. Mm-hmm. So, yeah.
So what that's going to bring us into for today's topic, this discussion of all these valuable karst resources, is how do we protect them, and what are some of the unique challenges the karst poses for protecting these resources. And in karst, as we've talked about through the semester, the surface water and groundwater resources are really one and the same. And contamination that happens because of the land uses and things that go on up where we live on top of on the surface can quickly get down into the subsurface and contaminate. Yeah. And
I'm even going to add in, that's sort of an interesting feature of karst. It's true of most groundwater systems that the surface and the subsurface water are related, but it's especially true in karst, which also adds an element. Many of the states east of the Mississippi, the older, earlier parts of the United States, have sort of an older, what's called a legal doctrine, that when courts rule court cases, they apply the doctrine that's been in that state from their constitution. And many of the eastern states in the U.S. have the legal doctrines that go back to before we understood surface water and groundwater to be connected. And so karst areas in those places may have real issues because the laws may actually have different rights for groundwater and surface water, even though in science now we know that those are one and connected. The farther west you go, the younger the laws are, the younger the state, and many of those states actually have groundwater and surface water laws that actually are based together. So yeah, surface water is a big deal.
In the state of Minnesota, where I worked for many years, they have a different state agency that has purview over groundwater than the state agency has purview over surface water. And I've sat in many meetings with the regulators in the state, and they sort of jokingly, but only half jokingly, say that springs are no man's land because they don't know if they're groundwater or surface water and who really regulates them.
And I've met people do the same thing with sinkholes in some states that say, oh, you know, while it's on the surface, if it goes out through a structure or a pipe that's part of the Clean Water Act, we care. But if it soaks into the ground and goes through a sinkhole, I don't have any regulatory authority, and that's the groundwater people's problem. So yeah, it's a challenge for anybody managing the land.
So clearly our regulatory structures are at least somewhat out of sync with our scientific understanding of the reality about how these systems work. And to bring that full circle, the comment I started on here about the connection between surface and groundwater, maybe the best way to state that is the rapid connection. As Doug pointed out, all groundwater and surface water is connected at some level and at some time scale, but in karst, we could literally have some sort of contaminant spill today. It's happened in Kentucky. Train wreck with dioxin, Agent Orange. A train wreck released a bunch of that chemical right into a sinkhole, polluted the groundwater, and basically killed the ecosystem of a whole cave and the water source for a town in Kentucky. And it's still, I don't even know, 50 or 60 years later, 40 or 50 years later, they're still dealing with the aftermath of that.
Yeah.
So it can be polluted overnight and still take decades to clean up. Yeah. So a lot of areas where we have karst, such as Springfield and southwestern Missouri and other parts of the country, have to have special regulations and special considerations for monitoring and protecting those water resources. And sinkholes are something that we've talked about in a different module and mentioned today.
Yeah, there's a different module, but even there I know that we talk about ponds and sewage lagoons, but not just wastewater plants, but many industrial facilities may have a pond, or even some farms may have a pond that accumulates some of their waste byproducts. And in karst, I often tell my students that a pond on top of a hill is probably just a sinkhole waiting to happen. It's by giving that water that gravity impetus, as we talked back in the sinkhole section, you're giving the water the desire to, the willpower, the drive to find the cracks in the rock and seep through them. And so the longer a pond exists, the more likely I think it will eventually probably collapse through. There are ways to engineer and design them safely. I don't want to say that can't be done, but it's a challenge.
You have to appreciate the landscape you're working on.
Absolutely.
I know, once again, back to my examples working in Minnesota, at least 2 major failures of sewage treatment plants due to sinkholes forming in the containment basins that they had. And in at least one of those cases, it was something they had taken into consideration building it, and it still failed within a short time after it was constructed. A common thing that's used in many sinkholes, if you've ever been in Karst country and gone out on the landscape or hiked around looking for caves or just hiked around, you've seen sinkholes filled with trash.
Oh, I think we used to make fun of every rural farmer where I was in Kentucky for many years, that if you had an old washer, an old refrigerator, apparently what you were supposed to do with it was throw it in a sinkhole. And of course, that's not what you should do with it. I need to say that as clearly as possible. Sinkholes, almost by their nature, with water running into them, normally will accumulate trash anyway. Just the paper bags that accidentally blow away from the parking lot, cups that people litter that blows off the roadside, the side of the highways. All those things often make their way to waterways. Many cities and states have a river cleanup day or a stream cleanup day all around the nation. Well, those things, if you let them go in the rivers and streams, eventually are going to find their way to a sinkhole if you're anywhere near a karst, if those streams or rivers flow there. And so you can have years and years or decades and decades, even if the landowner didn't dump it, other people who carelessly don't notice the styrofoam cup blowing out the back of their pickup truck can still have a contribution. And I say that because here in Missouri there's a fairly famous sink. I'll hold off on the name because it's actually named after the person's farm where it's at. But it's near Lake of the Ozarks, and I know that they've already removed something like 1,000 tires and 10 tons of trash from there. Most of the caving clubs in the state have 1 or 2 or 3 work days a year to just go up on a Saturday and get 100 people there and haul trash out. Eventually to open up and restore the cave that is at the bottom, because the sinkhole does feed into a cave. So yeah, please don't use them as a waste dump is our first statement.
Yeah, and of course, anything you throw in there, you're throwing right into your groundwater. Somebody, maybe you, maybe somebody else, is drinking the water that's flowing through that trash and into that cave system. And some of the trash may have very toxic chemicals or maybe leached of very toxic chemicals.
Or even if it's not toxic, sometimes in the Ozarks we even look at septic tanks in rural areas that were built and there just isn't maybe a lot of soil on top of the rock, or what soil is there may go right into cracks. I've been to more than one place where they turned on the kitchen faucet. They called me, this was in a job working in public health. They would call us and say, my water looks like really dark iced tea and smells bad. And I went to one place, and no sooner had the person turned on the faucet than I could look and say, you've got literally raw sewage in your well. And that was coming from a nearby septic tank. And so, yeah, you're affecting, it could have been their own septic tank for all I know. Sometimes that's why we do dye tracing and other tracing that we've talked about. But just the issue that whatever you put in the ground is, I think there's somewhere, I've heard someone use the phrase now for their community education, we all live downstream. Yeah. We're all living downstream of somebody else's discharge.
Yes.
And, it's pretty bad.
So we have an example here from actually some work I've done in the past related to some of these topics that tie some of this together. One of the things we're concerned about anytime we live in a karst area are the hazards, sinkhole formation. We have a slide here from the Living with Karst manual that goes through sort of the stages that, a hypothetical set of stages it might go through from no sinkhole to a sinkhole. In reality, the sinkhole was there all along. It's just now being expressed at the surface because it's been covered over with other sediments and so forth. In southeastern Minnesota, where I worked for many years, one of the big issues, and here in the slide I've got a picture of the largest feedlot in Winona County, Minnesota. It's 1,500 heads, so it's a lot of dairy cattle, but you can see the big containments. Those big pools there are actually big manure containments. Those are concrete with clay liners, and they're very state-of-the-art actually to contain the manure coming off of 1,500 cattle in those barns. Whenever a farmer in the area applies for a permit to build one of these containments, one of the concerns is always, is there going to be a sinkhole under that, because this part of the world has a thick soil, and often one day there's no sinkhole and the next day catastrophically a big sinkhole opens up, because it forms through a long period of time, but the soil's got just enough clay in it that you can sort of have a bridge over top until that bridge collapses. And that's always the concern that you put. And from the farmer's point of view, they would be responsible for the contamination, and a facility like this could cost millions of dollars. So you don't want to lose your facility to a sinkhole. So there's both an economic benefit for the farmer and a public interest in knowing that it's safe. On a different farm, not the farm I just showed, and actually in a different county in Minnesota, we did an investigation prior to the building of one of these, before the permit was applied for, due diligence investigation. And this is a profile, and we're not going to get into the geophysics here, but I've got it labeled. You can see there's what we interpreted as an air-filled conduit, some sediment-filled conduits, and then the bedrock, which is the orange and red and warm colors, versus the soil, which are the blue colors. You see a big variation in depth of bedrock. And so there are two issues here. One, you don't want to build that containment on top of those conduits that could potentially cause a sinkhole to develop. And in Minnesota, you had to have certain separation between the bottom of your liner and the top of the natural bedrock surface, so they didn't have enough soil here. Now, we ended up, this was a happy ending to this story. This site was ill-suited. They didn't even apply for a permit here. The engineer drew plans up for a different place 600 feet away, where we did a similar set of work and found a suitable site. And I believe they've recently gotten their permit now.
And that would be the good news. We're not doom and gloom people. It's an ounce of prevention is worth a pound of cure. It could cost you millions, if not tens, or in some places, some cities now are looking at hundreds of millions of dollars to clean up a sinkhole or to stabilize a sinkhole once it's opened up and repair the damage. But if you do, there are methods that usually can help us find things in advance. Will they help the average homeowner? It's probably going to cost more than it's worth to go study your backyard and see if we could find a small crack that might widen out over 50 years of owning your home. But if it's an industrial or commercial facility, if it's a large structure, if it's a shopping center or a government building, a large building, there are methods out there, and that's where it's beautiful to say an ounce of prevention is worth a pound of cure, because there are ways to study these, and there are people who are expert in this.
Yeah, and I'm always been proud of this work, because we're able to help balance the economic benefits and the tradition of agriculture and dairy farming in this region with the realities of doing that responsibly in this karst terrain, and balancing that out. And, our last slide here, just from the Living with Karst, says, "Karst is a resource to protect and enjoy," and I think that's maybe a good way to end.
It's our favorite, yeah. We get out and enjoy caves. This is Caves and Speleology, just to say these are beautiful places and fun places to be. Get out and enjoy them, but walk softly.
Yeah.
Tread lightly.
Well, that concludes this module. Thank you for joining us in Missouri Caves and Speleology.